In this video, I want to talk about the most important of Newton's laws, the third law. Newton realized that forces were inherently plural. That means that forces always occur in equal and opposite pairs. You read about this recently, and now I want to show you a couple of examples of the third law in action. Here I am, leaning on the wall. I could express this as a force in agent-object notation as teacher pushes on wall. According to the third law, the other simultaneous force is wall pushes on teacher. What is the relative size of those forces? We can use this tool, called a force plate, to help us out. It's basically a digital bathroom scale that can send data to our Logger Pro software. I'm going to put the scale up on the wall and lean into the scale. Notice that the initial force is 0, and then as I lean in, the force goes up. Once I am reclined at a certain angle, the force is constant. If this force represents the force with which I'm pushing on the wall, what is the force that the wall is pushing on me with? It must be the same size. Think about it. What would happen if I were pushing on the wall harder than it was pushing on me? What would happen if the wall was pushing harder on me? Here's a different tool. This is called a force probe. Logger Pro can measure how hard you pull or push on the hook. We can graph the force with which I am pulling in real time. The harder I pull, the higher the reading is. When I stop pulling, the force goes back to 0. Here is my favorite demonstration of the third law. My friend Tom and I each have a force probe. We're going to connect them to each other and have a little tug-of-war. You'll notice that sometimes he is winning and sometimes I am winning. When he's winning, is he pulling on me harder than I'm pulling on him? Let's look at the data. In fact, you can see that the two forces, me pulling on Tom and Tom pulling on me, are always the exact same size and in opposite directions. See how his force on me in green is the mirror image of my force on him in red? Now I'm sitting in my chair with a force plate in my hands. Mr. Coburn also has a force plate. He is kneeling on the ground. He uses his force plate to push on my force plate. You can see that when he pushes, I move and he stays still. He must have been pushing harder on me than I was pushing on him, right? Wrong. I moved more than he did because I was on wheels and he wasn't. Let's do this one more time. Now Mr. Coburn is sitting on a skateboard. When he pushes on me this time, he goes flying backwards. Is the force of him on me still equal to the force of me on him? Yes, it is. Newton's third law is true in every single situation, whether the objects involved are moving or not.